the polynomial function. And there's our definition. Basically, the first one I guess is a little bit trivial. Pn does not equal 0 because of course if Pn was equal to 0 then that wouldn't be the last term anymore, the one before it would be the last term. So it's trivial, but technically that's part of the definition of a polynomial. But that's probably more important. We know all the powers are greater than or equal to 0, and of course integers, they have to be whole numbers for it to be a polynomial. P0, P1, P2, as we know, they're called coefficients. The powers also have other names. We could call them indices. You know that. But the other word is exponents, hence why we call that curve the exponential curve. The degree of a polynomial, sometimes called the order of the polynomial, is the highest power. So a quadratic would be a polynomial of degree 2. The leading term is the one that has the biggest power. So Pn x to the n would be the leading term. Even though it's written at the end, maybe that's why we tend to write quadratics with the x squared term first, because it leads the polynomial, as opposed to the leading coefficient. So make sure you read the question closely and see what they're asking for, whether it's the leading term, in which case you would include the x to the power of something, or whether they're just asking for the leading coefficient, in which case you would just write the number. Monic just simply means that that leading coefficient is equal to 1. Again, some technicalities here. If you have the polynomial equaling 0, although I suppose technically it could be any number because you could always move the number to the other side, then we call it a polynomial equation. It's something to solve, go find the values of x. Whereas if it's equal to another pronumeral, then we call it the polynomial function. It's not an equation to solve, it's now describing a function. If we were to draw it, we'd get a picture of a curve. Now that brings up the distinction between roots. Roots are the solutions to the polynomial equation, as opposed to zeros, which are the values of x that makes that polynomial function equal to 0. So essentially it's the same numbers, but just a different term depending on whether we're talking about the equation or whether we're talking about the function. So the zeros then are the intercepts of the graph if you were to draw it with the x-axis. So we have this sort of question, no cheating here and looking at the answers on the sheet. Which of the following would be then polynomials? Now the first one, well, what do we spot? We go, well, hang on, no. We notice one of the powers is equal to a half, and we can't have a fraction as a power. The second one, no, because we would end up with a negative power. But x squared plus 3 is on the bottom of the fraction. Now, not that we can expand that out, but if we were to theoretically expand it out, we'd end up with maybe x to the negative 2 or something like that. Whereas the reciprocal of that would be the coefficient's allowed to be a fraction. There's no dramas there, so that's fine. And a constant number is a polynomial. It's a polynomial of degree 0, because you could think of it like 7x to the power of 0, and it satisfies our definition. Now this one here, okay, we have to work out, first of all, is it monic, and state its degree. And when you look at it, you think, oh no, it's not going to be monic, because look, you're going to have this x cubed times 8x, and x to the power of 4 is going to be the highest power, so surely it's not. But actually, if you expand the whole thing out, the 8x to the power of 4, and then, but later on there's a minus 8x to the power of 4. So they cancel away, and we get x cubed plus 2x squared plus 7x minus 8. So yeah, that is actually a monic polynomial of degree 3. A little recap of the definition of polynomial.